Hello everyone, this is Super CEO, and today this video is video number 5, continuing on from video 4. We're just going to do one question in this video, and as usual, before I start the video officially, and this short statement from Cambridge. Alright, so the actual question is question 12. The question itself is pretty long, so it's a big job to do, but stay with me. I'll guide you with step by step. Okay, now other than this part J, where it says technology, we're not going to really do that. You can use like Warframe or any other math software to do that. And the reason is because analytically you can't really solve it. So I think that's why it says you have to use technology. Okay, question A. Now, this time the little fx, or the frequency function, is given as a probability density function. So within that domain, it's pretty fair to assume that that little fx is going to be all positive. And also the integral from 0 to 4 is going to be 1. And in fact, that's what you have to do through part A and part B. Okay. And on top of doing that, you have to also state the mode from the sketching of it. Part C, okay, calculate the probability of x less than or equal to, or just less than 2. And what are the property of the curve? Makes us to do exactly the same job without actually having to do the CDF or the calculus of it. Well, let's have a look at. It's going to depend on the answer from part A, because you have to have the sketch first. And part D show that these two probabilities actually sum to 1. I mean, we can really see that straight away, because you notice this is actually the complement of that x less than 1. So no surprising that they will add up to 1, but we're really going to confirm that using algebra. And part E, less than half and greater than 3.5. What do you notice about the answers? Okay. And now part F is the CDF, cumulative distribution function. And then part G, just a matter of substituting 1.5 into f of x. That's going to be another one, so we're going to have a look at those two. I'm not going to really calculate these 4 to the end. I'm just going to show you what to do with this little, the big f of x to calculate each of those 4. And part H is to graph the CDF, and that is basically this, which is the primitive of that little f of x, or the integral of it. And part I, evaluate p of x less than 2 using the CDF, and confirm that the 50% of the data, that is the Q2, is x equals 2. So that's the last question. All right, so now question 1, part A, was to sketch that. So I'm just restating that little f of x with its domain given. So that's a nice quadratic function, and because of that little negative x, and that's going to give us a concave down parabola. And as you can see there, it's the two x-intercepts are 0 and 4. So there you go, and that's how you sketch it. And obviously, because of the symmetry, 2 is going to be the x value that makes the little f of x at its maximum. So straight away, then we can see that that's going to be the Q2, the median. Okay. All right. Now moving on to part B, that is to prove that the integral from 0 to 4 of that little f of x is actually equal to 1. All right, so that's I wouldn't say simple, but it's a fairly straightforward integration exercise. So integral 0 to 4, make sure when you're given a factorized integrand, you need to get that expanded like so, and then term by term, you get 2x squared minus x cubed on 3 in brackets, and don't forget to include 3 on 3, 32, as that's the coefficient of that whole thing. And evaluate it from 0 to 4, and at this point, you can use your calculator. I didn't have a calculator, so I had to do it manually, but it still gave me 1. So that's confirmed. So which means that, and because of the way it has been sketched, all the y values are positive within that domain. So these two confirm that, okay, that's indeed a PDF. And part C, okay, px less than 2 is, basically from 0 to 2, 3 on 32 of that, and that's giving us this. Again, exactly the same, but the two different x values to be evaluated. And if you do all that algebra patiently, you get half, which means that x equals 2 is actually the median. Now, you didn't have to do this to confirm that x equals 2 is the median, because if you go back here, the median occurs, if it's a frequency function that's given, then median occurs at the x value that makes the little f of x at its maximum, which is at x equals 2 by symmetry. So when the question says what other property of the curve makes us to say that x equals 2 is the median, well, that's because it's x equals 2 is the axis of symmetry for this particular parabola. Okay. All right, moving on to D, and remember you had to show that p of x less than 1 plus p of x greater than 1 should give you sum up to 1. Okay, so let's actually do the integration using CDF idea. So that's that one, evaluated from 0 to 1. That's that one, this, giving you 5 on 32. So the probability of x less than 1 is 5 on 32. Now greater than 1 is from 1 to 4. Remember, it ends at 4 because of the way the domain is defined. And again, substituted 4 and 1 respectively and subtract, then you get this. Now, obviously 5 on 32 plus 27 on 32 will give you 32 on 32, which is 1. So that confirms that the whole thing from 0 to 4 is actually giving you 1. Okay. Or like I said at the beginning of the video, that this is the complement of that. So we could see that 1 take away 5 on 32 is 27 on 32. Okay. So going back to this sketch here, see, from 0 to 1 would be halfway through there. That's 1. So that's 5 on, what was it, 32? Yep. And 1 to 44, that area under that curve, it's going to be 27 on 32. Okay, that's what it means. Okay, next part is E, is to calculate P of x less than half. So nothing surprising going on, just change your x values to be evaluated. Once you've found your primitive and substituting it, then you get this. Okay, now, next one is, now I said here, now by symmetry, we can say that. Okay, why? Well, let's go back to the diagram again. I mean, you could work out this, p of x greater than 3.5 using the CDF or the integral idea, but I got lazy, so I'm going to use the complementary idea. So here, what was it? Okay. It's not complementary, sorry, that's symmetry idea. So that's going to be 0.5. Now, see, that means that's half away from the origin, half away from the 4. That point on the x-axis is going to be 3.5. So that means area from 0 to half is going to be exactly the same as the area between 3.5 to 4 by symmetry. So if I calculate area of that little f of x from 0 to 0.5 or less than 0.5, because it's restricted by 0 anyway, that's going to be exactly the same as that. Okay, notice it has to be greater than, not less than, because of the way the symmetry works. It's between 3.5 and 4, so greater than 3.5. Hence, that probability is going to be the same as that, which is 11 on 256. Okay, part F. So that's the cumulative function. Remember, guys, when you're trying to work out the f of x, you have to use the n value as x, and all the x is now replaced by the t. That's the only thing that you have to really be careful with. And then replace all the t's by x and whatever the starting value that you got given with. So here in this case, when you substitute 0, though, it's going to be very easy, all 0. So just replace all the t's by x, then you get that. That's your cumulative, or the CDF, in terms of x as a function of x. Okay, now this one, so that's going to be the same as p of x less than 1.5, and that's going to be the probability of x, big X, between 1 and 1.5, okay? And that's between 3 and 3.5, and that's between 2 and 2.5, which is exactly what the question is asking. Okay. All right, next part is to graph it, graph the big F. So here the CDF, we are given like this. That's an expanded form. To graph it, it's better to put it as the factorized form. So it's a nice E11 work, taking out the common factor, like so. Okay. So where did I get the third from? Because that's 1 on 3. Okay, that's the least common multiple. If you can force it to be the least common multiple, that's third. Then that becomes 6 because it has to be 2. Third times 6 is 2. Okay, and that's now x. Now, then 3 and 3 cancels and gives you that. Okay, so that means in the vicinity of x equals 0, this is a cubic, obviously, but in the vicinity of x equals 0, it behaves like a parabola, and in the vicinity of x equals 6, it behaves like a linear function. So then you get this, all right? Now, why is it this shape? Because of that, okay? For a cubic function, you either have this scenario or that scenario, okay? All right. Now, this happens when the leading coefficient, that is the coefficient of x cubed, is less than 0. Okay. Now, here the leading coefficient is minus 1 on 32. Okay, because that minus 1 on 32 is the coefficient for x cubed, which is the leading term. So hence it takes this cubic function. So hence it's going to be like that. Remember how I said in the vicinity of x equals 0, it behaves like a parabola, and in the vicinity of x equals 6, it behaves like a linear. So that's linear, okay? If you zoom in very closely. Okay, so, but the domain only goes from 0 to 4, so I can stop there. Now, how do I know that 4 is the maximum point? Well, come back to this little f of x, which is the derivative of big f of x. From the question, we know that it's 3 on 32 x bracket 4 minus x. And when that becomes 0, that is when the first derivative becomes 0, that's whose x value, okay. And the solutions to that equation are stationary points, which are 0 and 4. So hence, so we know that that's going to be the minimum point, and therefore the 4 has to be the maximum point. So it stops there. Okay. All right. X less than 2, the last one. If you substitute it into big F of 2, so that's the definition, is going to be 4 over 32, because over here, if you substitute x equals 2, that's 4 over 32 times 6 minus 2, which is 4. So that's where you get that from. 16 over 32, which is half, hence x equals 2 is the median. Okay, so I hope that helped you guys with this question 12. Okay, so that about does it for this video, and I'll see you guys next time. Thank you.